and welcome to this week's freezing episode of BroPartisan Hacks. I actually can't believe we were able to do this today. Earlier this week, I thought there was no chance that we were going to do an episode. So, feel pretty fortunate. Both have power. Both have water. I have water. You have water?
I have a boil water notice still.
Oh,
so I'm filling my coffee machine with a bottled water.
We got an email last night that said we don't have to boil our water anymore. So we're going to run it through our pipes for a little bit.
Run the bathtub for a while and just let it do its thing. Spend about $300 on water because that's good for the situation.
Right. Well, I think we had already spent at least that having our taps on, the whole week.
Yeah. Did you guys because you had your taps on? I'm sure y'all didn't freeze any pipes or anything.
Oh, we actually were very, very fortunate. We, I feel really blessed because we we had rolling blackouts here at our house, and so it would go 20 minutes power, 10 minutes no power, 45 minutes power, 30 minutes no power, and it would just kind of roll like that, and it was at worst annoying as balls because you'd be in the middle of something and then all of a sudden the power would go out. And so you spend the entire time that the power is on anticipating it going off because there was no pattern. There was no it's going to be 30 minutes. It's going to be 10 minutes. It's going to be, this is what it is. It was just
random.
Whenever.
Yeah.
It's just so, and so I feel like awful complaining about it because I'm listening to I've got a group chat of my buddies from high school, and so one of them had a bust pipe. He and his family had to move out and move into a buddy's house for this week.
Yeah,
they're moving in today into a hotel, so for however long it takes to repair the home because from what he tells the entire house was flooded.
Wow.
One of my friends has been stuck in Seattle. He went there last weekend and is still there. Never got to come home. Another one is a firefighter, and he has been home for some total of 4 hours for the last 6 days. So I'm really, really fortunate. I haven't left my house but twice, and that was to go to the store that's right around the corner. So we've had warmth the whole time. I read the story that Mom posted about the little boy who they piled blankets on, and he got too cold and died in bed. And I was just, man. I was prepared to start fires in my house.
Yeah.
I was like,
I'll burn this couch to the ground to stay warm if we need to. I got tables here that are just stacked up. I don't need it.
I was ready to roll the whole grill inside. I told the wife, I was like, there's whatever it takes. But our house never got below 55 degrees. We were really, really, really lucky. So, we just kind of hunkered down, we were able to charge phones, charge our portable battery chargers.
Yeah, we couldn't use our phones for a day and a half. And I don't know about you, but we lost network entirely. All the towers froze and everything. And
oh, wow. So we lost reception when our power was down, but it's when the power came back on, we had Wi-Fi. So you would send me stuff, and I'd be like, "Oh, look at this." Whenever the power comes back on, I can't
look at it right now. Yeah.
And so, but we there are so many things that I have, like my laptop. I could plug in a movie into it that I just didn't think of to entertain the kids. and they, they were having fun. We gave them the flashlights, and they were running around the house, and going exploring with the flashlights, and it was super fun, but also nerve-wracking. So,
right, because you're sitting there going like, is the heat gonna come back on? Is my house about to freeze? And that's mostly why a lot of the people had damage to their homes, like with those pipelines that are like in the attic and everything.
Yeah.
Underneath the house, underneath the house, they're supposed to be insulated. But if construction companies cutting corners, then your pipe underneath the house, if you've got like a crawl space underneath there, the wind blows through and just freezes those pipes, and so.
Well, and a lot of those regulations are new, and so if you have an older home, you definitely, if you haven't changed that stuff out.
Yeah. Or even go into there to insulate it, because it doesn't take much to do it. I know that going Sunday afternoon, because I live on the coast, and I was like, you know what, man, it's probably not gonna be that bad. And then I'm like looking at the temperatures, and they're like, yeah, no, this is pretty set in stone. Like, it's gonna be 5 degrees outside, or 3 degrees outside, and it's gonna be cold. And I was like, man, I guess I should do something with the outer, faucets. And of course, it's the day before the freeze, so every cap is gone. Like all those little like foam caps, so they're sold out in the entire region. And they were sold out like last week. Every single one of them. So then I'm like, all right, well, packing foam. I can do packing foam, and that was sold out. And all they had back there was like bubble wrap. I'm like, what the fuck am I gonna do with bubble wrap on this spigot? This ain't gonna stop anything. But I was at a Home Depot, and I was looking at it, and all they had was bubble wrap. But then I look over at the carpet section, and they had that recycled foam carpet rolls. Mm-hmm. Yeah. And I was like, hey, nobody's been over there, because that would be gone. So I wander over to the carpet section. I'm looking around, and those like non-stick cabinet liners that you can buy with a little holes in it. Yeah. So they had one that was like solid, with no holes in it, and so I bought that little foam roller pad, and it was about 2 inches diameter of a roll. I took it home and I cut it into strips, and then I just wrapped the pipes outside with that, and we didn't have any problems with it. I definitely had to scrounge for resources here. I don't know if you've seen the pictures.
I just used duct tape and some towels.
Yeah. That was where I was going to next, if I couldn't find like some kind of foam or something, because I was like, well, it's better than nothing.
Because the caps that I had from last year, the dog ate. So
I know I destroyed one of them because I was so friggin' lazy when I was like doing my yard one time. No, I hit it with a lawnmower. A weed eater, actually. I hit it with a weed eater, and it split it in a million pieces. And then I was like mad at myself because now I got to pick up all these little foam bits all over the yard.
Yeah.
I was like, no, this will be fine. It's not gonna. It'll just move it out of the way. No.
So, we I got really annoyed this week with some of the things that were said about this outages. On Fox News during the day when they have their like straight news
segment,
straight news shows, 48 times the panel host / guest, whatever, blamed the Democrats. 80 times on the evening Tucker Carlson and Sean Hannity shows, they blamed the left.
Wait, is that combined with the Hannity and Carlson?
So 48, yeah, it's 80 between Hannity and Carlson
together. And it wasn't individually, because I feel like those guys are rookie numbers. Like, these are rookie numbers right now, and they need to pump those numbers up.
I mean, this was like the whenever it first started. So these are early numbers. Early,
okay. Early,
these are
like
early numbers.
Monday night, whenever our power was out, kind of thing. Yeah.
Yeah. So these are really early numbers. Here's the thing. How in the flying fuck is it the fault of the Democrats when Republicans have been running Texas for 30 years? How do you draw that conclusion? I don't understand.
So
30 years.
It's a convoluted answer. And the thing is I was going to get into this. So if you want to go to like dive right into like specifics and technicals and kind of what happened, my understanding of it.
Let me do this one more thing before you get into technicals, because here's the other thing.
All right, so okay. 30.
So these are my memes. All right. The other thing, green energy is to blame. I got into, when we started this thing, I made myself a promise that I was no longer going to argue with anyone on Facebook. Like I was just like, I'm done with that, right?
I'm gonna just argue here. This is it.
All right, this is the only place I'm gonna argue. But I posted this thing where I didn't really understand why people were blaming green energy, because it's negative 54 degrees in Antarctica, and they have windmills that produce energy there. It got to 10 here, 5, single digits, 7, 1. Mm-hmm. That's still warmer than negative 54, right? So I don't think their windmills are frozen. I don't think they're frozen on the northeast coast. I don't think they're frozen up in like Montana, where they have big windmill farms. And so people are like, no, it's the Green New Deal. Green energy is to blame. Blah, 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 blah. And no, I mean, I did see that it cost $150,000 per unit to winterize the windmills.
Okay.
So a choice was made. Right? A choice was made to not do that, to not spend that money, and they didn't have to. Right? They didn't have to, so they didn't, because it's not regulated. There's nothing that says they have to do a thing, because it's their choice. It's for profit. That's what it is. So, let's, anything else I got? Yeah, that's all I got for my memes of this thing. So, explain, for those of you that don't know, Rob is an engineer. Rob understands a lot of the things that us plebeians do not understand. So what I wanted to do today was have him kind of go over what exactly happened, what could have been done to prevent it, and kind of explain some of the technical things that most of us don't know. And I just want to kind of be the Joe Rogan doesn't know anything, ask questions guy while he does this. So have at it.
All right. So I guess the first question is actually, I have a series of questions. It's just kind of understanding of like how electricity works. Do you have any concept, and just Mr. Brogan here, do you have any concept of like what a volt is, what is voltage, what is an amperage, and then like what is resistance? These are like the three basic components to any electrical network.
So, no.
Okay. So the answer is no. Then I'm just going to break it down real basic, right? So you know how pumps have, like if you had a water system in your house, right, and you would have you have a pump that builds up pressure, okay? You have the flow of the water, and then you have whatever friction the pipes give you. So if it's got to go through like a weird path, then it's going to have a high friction, right? So you can think of amperage and voltage as your flow and pressure. So voltage is pressure, so it's the potential of energy, right? So like a voltage in your house typically runs in, it comes into the house at like from a transformer on the street, it might be like a 120. Here in the States, at running a 60 hertz AC current. So we're going to talk about AC and DC because that's important too. It's actually critically important for the reasons of like what happened and kind of what went down.
I know that in order to have a light, you have to complete a current.
Right. You have to make the loop, right? And I can make a light power through either AC or DC current.
Right.
I'm going to try to avoid talking about like how Edison was a little POS and Nikola Tesla developed AC current, and then everybody went to AC current anyway. It turns out it's better and more efficient for the way that we use it. In any case, and resistance is basically just the friction in the pipes, right? So everything has a resistance, and the resistance is really kind of what gives flow. You could also think of resistance as a load, right? So if you have a circuit, like you said, you complete the circuit, you make a full loop, you close it, and then it lights up the light bulb, right? So your light bulb is actually providing the resistance for the circuit. And there's a basic direct correlation where it's like I think it's I'm gonna mess up the most basic thing, but it's like voltage equals current times resistance or something like that, right? So if your resistance is 0, then you have no voltage, okay?
Okay.
So you have to have all three components. Next is how is power generated, right? So power is generated in a sense today by making something really, really big spin inside of coils, and so you have a big metal ferromagnetic shaft, which is just a piece of iron basically. And you have to have your conductor coils, and this thing has to spin inside the coils, and then it generates a magnetic field, which then moves current to the lines, right? To the coiled wires that are coming off the coils. And that's really the most basic way I can break down like what a turbine is and what a generator is. And every single piece of equipment that's ever been developed, to my knowledge, that it's in mainstream use, is based upon this principle. You spin something, it generates a current, right? And that's it.
Is that including nuclear? Because I know that like nuclear is like
Yeah, so the way nuclear works, and we can talk about that, but nuclear energy works is basically like the radioactivity that's given off by whatever your fuel source is generates a ton of heat. Yeah, well, uranium, plutonium, you can use either or, right? And then a lot of, again, this is going back to like one of the classes I took in college, so it's a little rusty on this stuff, but like one of the byproducts of a uranium facility is plutonium. So then like uranium is naturally occurring in the world. Plutonium isn't, right? Or it is, but it's like got to be a bajillion years old, before it actually reaches the half-life naturally. And so it's something like that. Don't quote me on that. But plutonium is a byproduct of uranium usage. And so, you could have like 2 sister nuclear factories or plants. Anyway, so they give off heat, and then it creates steam, and then the steam moves the turbine, right? Just like a normal coal generator.
Okay.
Right? The only difference is the fuel source, right? So everything moves something spin. Everything. Hydroelectric plants just use the water to move the turbine. Wind turbines use the wind to spin the turbine. The only thing I've seen that's unique was it was like a wave generator. Not wave generator, but a wave power capture thing, and they're off like the coast of Scotland. And so they're these long arms that like sit out in the ocean and ride the waves, and they somehow generate power through that. And that's really interesting.
Cool.
I'm not 100% sure on how those are creating a current, but they figured it out over there, and it doesn't do much for them as far as like real generation, but it's like 100% green, and there's like no maintenance. So
heck yeah. Cool. I mean, if you can make that more efficient, that'd be a decent little energy source. It's kind of never ending, right?
Yeah, I mean, well, it freezes in north of England, but
I say never ending, but we'd find a way to fuck that up.
yeah. Well, and eventually everything breaks, right? So at some point, there's no machine that an engineer and a physicist can make that's going to be perfect and run forever. It's not going to happen. Something's got to be lubricated. Something's got to be. It's going to have some friction on it. If it's got friction on a metal piece, it's going to wear, and eventually it's going to wear out.
Right. I was listening to some guys yesterday. I can't remember what it was, but they were talking about nuclear energy. And they were talking about the biggest issue with nuclear energy is when things wear out. Like, so, whenever you talk about, because we mentioned when we were talking about clean energy, you said if any conversation about clean energy that doesn't include nuclear is disingenuous. Mm-hmm. And so what they were talking about was the difference between nuclear energy and coal and oil and gas is when things go wrong with nuclear, which isn't very often, it's few and far between, you see the effects right in front of your face, right? You can go to Chernobyl, you can go to...
I wouldn't, but you could.
Fukushima. Right, yeah. but you can see what happened, right? You can see with your eyes what happened. What you can't see is the effects to our atmosphere that coal and oil and gas cause. Mm-hmm. Like it's not in your face, right? And so
it used to be.
It's true.
I'm just gonna say, like it used to be, because a lot of times you would go to like coal refineries and you'd have this giant black plume of smoke. Now, granted, this wasn't in either of our lifetimes, right? But this was like back in the 50s and 60s. You see pictures of the old coal plants, and there's just these giant chimney stacks just burning stuff off, right? If you go to the old foundries where they were using coal, like in Pittsburgh, to make steel, you just have giant black plumes of smoke coming off, right? And so a lot of the scrubbers that they use nowadays, they are pretty impressive. Now, again, it's not going to get the nod from the green energy enthusiasts, but like, it takes out about 90%, 99% of all the rest of the stuff. And so the only thing that most of those coal plants are putting out nowadays is CO2 and water vapor. Like that's really it. And
I think the CO2 is what
they're blaming us on, right? So, but yeah, no. So that's the thing. Again, the biggest polluter of the carbon stuff used to be the NOx and sulfur oxides, nitrous oxides and sulfur oxides that were given off by the coal plants. And so, anyway, so nuclear, you see it. Coal plants, you don't. The other thing that you don't know about nuclear plants, you probably don't know, is that everything is like minimum of like triple redundancy nowadays. And what I mean by that is, like, if you have to have a water pump running. Now, a water pump would be a critical component, the cooling pump for like a nuclear plant, that would be a critical component. So they're required like a minimum of like 4 pumps that can run that system. And every single one of them has to be active, right? Or at least be able to be active. So you may only need to run one to keep the reactor safe. But all 4 of them have to be, or the other 3 all have to be ready to be turned on in event of this one shutting down. And it's like that with every single component that's on this thing. And there's different like rating classifications of like how critical something could be. If you really want to get in, like, we don't need to get into that too much.
We don't have to.
Yeah.
We don't have to.
There's the amount of regulation that's on this, and I've talked to engineers that work in the nuclear industry, and some of the young guys who like come in and like, man, I'm going to do great things, I'm going to make all these changes, and it's like, no, you're not. You ain't going to change nothing. If you're an engineer working in a nuclear facility, you are a glorified bureaucrat, because any changes you want to make, like, say you want to do something as simple as like, hey, this little gasket here on this pump isn't the best thing. We need to change to this different material. That goes all the way up to the federal like nuclear review board.
Oh wow.
And then it's got to come back down. So your little bitty 1-inch gasket change can take like 3 to 6 months to get all the necessary approvals. So it's kind of a big deal when they say like, hey, we're going to do this thing a little bit different. No, you're not. Like it is. And I complain about like making changes where I work, you know, like, hey, I could do this and it'd be cool. And I just have to deal with like 2 different companies and get them to agree like, hey, this is the best course of action. They have to go through like 5 or 6 levels of approval for any change.
That's just right there.
Yeah. So it's kind of a big deal when you go to talk about how a nuclear facility especially is managed. Now, coal and everything else, no, they don't have that. They don't have near as much because coal is an unregulated fuel source essentially. You know, it's just you can't build a bomb out of coal, right? So.
All right. So what happened? Moving back.
Moving back into what it is. So, to answer that question, I have to ask you another question.
All right.
Why do circuit breakers trip?
They get
They get overloaded, right? They have too much
overloaded,
going through them.
Yeah.
So what causes the circuit breaker to trip? What mechanism is that? It's heat. Okay. So when a wire is drawing current, it heats up. And so wires all have to be rated for a specific voltage and current. So every wire has a very special rating. And if you know the wires in your house are like little bitty ones, right? And you go outside and then the ones on the cable lines are a little bit bigger. And then you go to those major transmission lines and those cables are like 6 inches, 8 inches thick, right? Mm-hmm. They're big. And the reason for that, it has to do with efficiency. So voltage is transmitted at a much higher efficiency the higher the voltage you can get it. So you remember I mentioned that the voltage in your house is about 120 volts. The voltage on the power lines is probably about 4,300 volts, the ones outside your house. So it's pretty high, right? The ones on the power cables, the big transmission lines, are in the neighborhood of like 43,000 volts to like 80,000 volts. And sometimes higher. Lost my train of thought there.
Yeah.
So anyway, so when the rating of the circuit breaker doesn't match up with the power demand at your house, it's going to pull more current through the line than the lines can handle inside your house. So really what they're doing is they're keeping your house from catching on fire and the wires from melting. So you don't ever want, like if you're overloading a circuit, you don't want to do that, right? That's bad.
Right.
So the same thing can happen on a major scale, right? Okay. There are circuit breakers that trip at like major transformer and switching stations, right? So they all have, everything is protected from itself. Because the mechanism of electricity is like if I have a power source on one hand and then I have a motor over here and then I have a circuit breaker and I've got this electric motor and I'm trying to run this motor and it's rated for like 20 amps, right? It's small, right? So I put a circuit breaker in there that'll handle like 21. And so it'll protect the amp, the motor, from overloading and burning up. That's what the circuit breaker is there for. If I put too high a load on this motor and say, I just like lock it up, right? And so I just turn it on and it locks up and it's not turning at all. That motor is going to pull power as much as it possibly can. Like it doesn't care about what it's rated for. I was talking about motors, and I mentioned that a motor, and this kind of works with any electrical device, but a motor is going to pull whatever it needs to turn, right? So if you've got energy going to a motor, and really any electric device, like a microwave or whatever, right? It's just going to pull current That's all it does. And so when it pulls the current, then it actually energizes and turns. If it can't turn, it's going to keep drawing more and more current to generate more and more torque. Okay, so if you don't have any limiters in the equation, which is the circuit breaker in this case, it's going to melt, right? It will pull so much current that it overheats and melts the wires. So, with that understanding, let's talk about kind of what happened this time, right? So, if we go back to the beginning, and I haven't, some of this is unconfirmed, some of this I've been able to piece together, some of this I know because I know how it works, right? And I kind of know how industry works. So if you have any questions, obviously just stop me and let me know.
Okay.
Right now, you've got both the green energy groups and the fossil fuel groups pointing the finger at each other because no one wants to take responsibility for everyone losing power. I think at the top count, it was like 4 million people was the number I saw of people who had lost power in their homes.
Yeah, that was at max. That was
the
peak.
max, right? So that's a lot. There's like 34 million people in the state of Texas. So 10%, 11% of everyone in the state just lost power. And some people lost it for days, right? Like our parents, they didn't have power since Monday, and I think they got it back last night. That's a week, right? 5 days. And they're old, right? So like that's not good.
Yeah.
They do have a fireplace though, so that's good.
They said it wasn't worse-ish though. That's what they told me.
It wasn't working. What?
Wasn't worth shit.
Oh yeah.
It said that it was like.
It's a fireplace on the coast, so.
Right.
It's not exactly like a New England fireplace. Anyway, so I was on the verge of inviting them over here because of where I live. I'm across the street from a college, and I think I'm on the grid with some major chemical plants. So I was like super fortunate that we only lost water here.
Yeah.
Like I had power the whole time, but I didn't have internet or phone or anything else. So like we were very lucky. Just because of where I'm located on the grid. And I went out to like other houses, you know, when I would go to the grocery store or whatever, and like every house or every business at least between where I live and the grocery store was like out of power. The street lights were out, but I had power at the house. And so like a block away, I had power, like there was no power, but we had stuff here. Yeah. So we're very lucky.
My oldest son is on the same, he was at his mom's he had to go quarantine because it's another story. I'll tell it later.
Yeah, we'll come back to that.
He was at his mom's, and she lives close to Baylor Hospital, and so they never lost power.
Yeah, it's one of those things that's like I didn't even think about like. Either I'm on the grid with the college or I'm on the grid with the chemical plants, you know, my workplace. One of the two things has occurred here where we're okay in this neighborhood. In any case, so let's back up. So before the freeze happened, they kind of had an idea that it was going down. And ERCOT had requested approval from the Federal Department of Energy, to basically intervene on their behalf with the EPA and TECQ, Texas Environmental Quality Commission, or Commission on Quality, or something, whatever that, TCQ. It's basically the state regulatory agency that governs emissions and volatile organic chemicals, right? Mm-hmm. And on the 9th, I haven't been able to confirm this, but it's been reported that on the 9th, they had requested a leave to basically forego what their emissions limitations were with the upcoming freeze. Okay, so hey, we got an emergency situation. We can generate a ton of power, but you got to let us like basically cut some corners here. It's kind of what that means, right? we can do all these things correctly, but with the reduced rates and with these low flows, it's not reduced rate. With normal rates, we can't increase to exceed our emissions allowance, basically from the state and from the federal government. So they asked for a waiver on the 9th for that, saying, hey, we need to generate more power. Okay? That didn't happen. They did not get that grant for the emergency purposes. So rolling around to Sunday, the officials kind of knew. Again, you can read this, and I've kind of pieced together a lot of this from a lot of different articles. The freeze started happening, and the temperature started dropping. The first things to go were the wind turbines in Texas. It was the very first power drops. And going off of the ERCOT numbers, so their winter... So there's two different things that happen with wind turbines, right? You have what they're rated for, and then you have what they actually produce. Mm-hmm. The ratings, like the sticker ratings on these, all the wind turbines in Texas is somewhere in the neighborhood. I've gotten conflicting numbers based on different things. The numbers that I saw in ERCOT for what they're actually rated for is about 32 gigawatts or 32,000 megawatts. Which is a lot of energy, right? Like Texas has the most wind energy of any state, period. Yeah. Because we got West Texas, right? I mean, you just plunk a wind turbine down there.
Tons of wind farms out there. Yeah.
So the first thing to go were the wind turbines, but they only lost about 6 gigawatts. Right, because that's about all they were generating at the time. So they could put up like 32. Really, it's more like 6 or 12, right? On the best days, because you can have wind gusts, and then they have to be braked. And if your wind gets up too high, then they have to actually shut the turbines down and like lock them in so they can't spin. Yeah, so like if the brakes fail on a wind turbine, there's some really cool videos on YouTube of them basically just breaking into a million pieces. Because I mean, the vanes on those things are like 200 feet long, right? They're huge. Yeah. So if they get spinning at like a couple hundred RPM, they're gonna bust. Like they can't sustain the load, and they just tear themselves apart. So yeah, wind turbine brake failure. Look that up. Those were fun. But anyway, so the first thing to shut down was the wind turbines. And that was Sunday night into Monday, right? So they froze first. And we talk about loading, right? And we mentioned how circuit breakers can trip. If you've got too much power going to one circuit, it'll trip that breaker. So what happened when the wind turbines went down is that you had all this power coming in from West Texas, right? And the wind farms out there. And then all of a sudden you didn't, right? Because 6 gigawatts is still quite a lot of power. At the time, it was about 4% to 6% of what they were putting out for the state at the time, okay? But a 6% drop immediately, essentially, is a huge number for everything else to kind of compensate for. So the grid is all interconnected, and everything else kind of ties in together within the state of Texas and the ERCOT region. And so you had a shutoff in one area, and these other plants had to pick it up. So what happens to the switching stations that are kind of in the middle, right? Now, instead of having a balanced load coming in from one side, going the other, and going this way, you've got all your power coming in one direction and trying to feed out multiple points. Okay. And they just simply overloaded. And so the first thing to go down, again, the wind turbines, then the switching stations that those were connected to, that were actually the distribution points to about, I want to say like a few 100,000 people were affected with the first blackouts. So that was the first thing that happened, right? And that's why the shutdown actually affected people at the point of the wind turbine farm. So now you've got the oil and gas and the coal fires and the nuclear plants that were still operational at that time. Okay. Now, the gas turbine makes up about 53% of the energy production in the state. They're super efficient. Gas was really, really cheap recently with the fracking, so a lot of people built gas turbines. And the gas turbine outputs that I've seen, they had increased output, in some cases up to like 450% output. So these things were running basically as harder than they ever were designed to, in a lot of cases. A lot of the coal production facilities I saw had increased power output by 100%, so they're now running at 200% capacity. And that was because on Sunday night, the EPA and the Department of Energy finally came to an agreement that they could bypass the emission standards. They say, hey, this is emergency purposes. You guys put out the power. Get it done. And so they did. And then all of these wellheads, you see in the news about the wellheads. So wellheads in Texas are basically just like holes in the ground. That's really it, and the wells are typically just an underground cavern. And the way that you get gas out of these, in a lot of cases, you can use two different mechanisms. One is to fill the wellhead with nitrogen. And so you pump nitrogen. So there's a cavern underground that's full of gas, right? This is your fuel source. It's like a big fuel tank for the plants. And what they'll do is they'll pump nitrogen into the ground underneath it to pressure it up and they'll have the tube basically down at the bottom of the well. And it'll push the gas of whatever natural gas you have in there out of the wellhead with the nitrogen pressure coming out, right? You push something in, the gas comes out. And sometime around, I think Monday at 2 a.m., the water started freezing. And we started losing major distribution hubs. I know that I got a letter from my city saying that within 30 minutes they had dumped 100,000 gallons. They just lost it, right? It just poured out wherever it is, So the whole system drained across the state because none of this stuff is winterized, right?
Right. No.
For the major distribution centers, like we live in Texas, it doesn't get
Why would it be? And that's one of the things, like, yeah, I've always, like, through this whole thing, I understand why you wouldn't do it.
Yeah.
It's a huge cost. Like I said, for wind farms, it's $150,000 per unit.
That's just for the equipment. That's not to pay the people to go out there and install it. That's not to get the rig, the massive rig that you got to get it out there to install it on the wind vanes. So like that just barely scratches the surface. So really the cost to install one of those things is probably closer to the neighborhood of like $500,000 or $600,000 just for the people and the equipment you need to do one unit.
And there's hundreds, if not
and there's
thousands.
There's thousands of those things.
No, I mean, I get it. I get it. That's all I'm saying. I understand why they didn't.
The cost to retrofit is astronomical. Now, if you were to like build new, it's a shot in the dark, right? It might cost you $1 million, $2 million to build this wind turbine, right? I don't know how much they cost. I'm just shooting in the dark. I know how much materials cost. It might cost you $1 million to build a wind turbine, right? And so if you tack on $150,000 to the price tag of that to winterize it when it's in construction, super easy.
Yeah.
But now you're paying 50% extra cost on something that's already in service, that's already out in the field. You got to get the equipment there, and these things are in the middle of the field in Texas, and that is not easy terrain. Like over in West Texas, that's desert, rocky, terrible. It's not good, man.
Yeah.
So yeah, it's cost prohibitive, right? And we're going to talk about that. There's a lot of things that are cost prohibitive. And there's a lot of reasons, and a lot of this does tie back to money.
Obviously.
And a lot of it does tie back to what we in the industry would call like a credible scenario. right?
Okay.
So we'll get to that. Credible scenario. Remember that phrase. That is a specific term that is used. Where was I at? So wind turbines shut down, water started freezing. So water that's moving doesn't really freeze, right? If you can keep it running water, you might, like at a surface of a creek, you might keep the top layer might freeze, but the water underneath keeps running, kind of deal.
Yes.
Water is pressurized in these systems, so this is something to consider. When you increase the pressure in water, it takes less time to freeze. It freezes at a higher temperature. So if you have water at like atmospheric, like a lake, versus water in a pipe that is static, but under like 10 pounds of pressure gauge, the water in the pipe is going to freeze first at a higher temperature, right? So it might freeze at like 34, 36 versus like the 32 normal freezing point that we think of.
Right.
Because pressure plays a factor in that. So water systems in most municipal districts operate at between like 30 and 35 psi. It's just part of the chlorination process that they use to purify the water for us, right? So that it's actually like safe to drink. It's what they use to kill all the microbes. It has to like pulling my shirt open, yeah, so you can see. It's got to get up to a specific pressure before the mechanisms are activated to clean the water. So a lot of these municipality districts have like what's called dead legs, and it's basically just a point in the pipe where you'll have like an old T in the pipe, and instead of like rounding that elbow off, they'll cut the pipe off and just weld the plate on the end of it, and so you have static water that would sit in that location. So that happens sometimes, and I would hazard a bet, because that happens so frequently, that's where the break started, right? We have that out where I work. I think we had broken off. Last count in my facility, and I work at a small facility, I don't know, 30-something leak points where just the pipes burst. And we're scrambling to replace them right now. So, it is what it is. Our water systems aren't insulated. We have a cold water system. That is insulated because we got to keep it cold. Right. but
that's where we live.
Yeah, like the cooling tower system.
We more have to take care of the heat and worry about the heat than the cold.
I got cooling loops on a lot of different systems just to keep them cold, because getting them hot's not a problem. Getting them too cold is an immediate problem. So anyway, so the water pipes burst, right? So what happens when water pipes burst? Well, if the whole distribution network goes down, which is what happened in most major cities across the state, and rural cities, really. Everybody kind of lost water for a little bit, which was very, very dangerous, right? You can only live a few days without it. The state's resources were fairly tapped because of there was an incident down in a city that had the brain-eating amoebas, right? So they had people bringing water in. That was late last year. They had a kid die at the
actually that was a friend of mine's daughter.
What was it? Really?
That died. That was they were from Whitney.
Oh my God. I think that was the kid's name in the news.
No.
Are you talking about what happened in Whitney at the lake?
No, it was in the river, the Brazos River. That was no. She caught a brain-eating amoeba in the river. And what was her?
Anyway, the point of that story was to say that the bottled water resources of the state are pretty much tapped out before we went into this. Now, whether or not they resupplied, I don't know, but at least 2 different occasions last year they had to supply counties with water, bottled water, to like keep people, alive, basically.
Yeah.
So what happens when the water goes down? Well, if you don't have a source of fresh water and just replenishing condensate water system, you can't really run a steam turbine, right? So, so when the water pipes froze, a lot of these plants just had to shut down because if I don't have water, I can't make steam. And if I can't make steam, I can't turn the turbine, right? And it doesn't matter what your fuel source is at that point, whether you're nuclear or gas or coal. It doesn't matter. If you can't get water to make steam, you can't make power. And then the nitrogen plant shut down. And this kind of affected us pretty heavily. So there are units that people can get. They're air separation units, and they basically strip the nitrogen out of the air, the atmosphere that we breathe, and they pump nitrogen everywhere. Now, nitrogen is important for more like the chemical industry than the power industry, but the power industry also uses it, and they use it for like as basically the inert gas to move the fuel cells, move the fuel around, like I talked about with the wells. They use it to clear the equipment whenever you go to work on it. They'll use nitrogen to sweep and purge all the chemicals out of it, whatever they're, if they're pumping oil or whatever else. They'll sweep it with nitrogen to try and dry it out as much as possible before someone goes and actually works on it. They also have to do that when they're putting it back together and they're recommissioning it. They have to sweep it with nitrogen to get all the moisture out of a turbine before you can start it up. So if you don't have any nitrogen, you can't even start your turbine back up, even if you need it and you have the supply and the water and everything else. So all these things are like interconnected throughout the state. So nominal production of the state is about 81 gigawatts or 81,000 megawatts. You'll see it in news both ways, both gigawatts and megawatts. So 81 gigawatts is like a billion watts, right? That's a lot.
I mean, it's not close to. I mean, it's a little bit more than 1.21 gigawatts.
Gigawatts, yeah. I think that's a real thing.
1.21 gigawatts.
You could say, I guess you could say it with a hard G instead of a soft G, or a soft G instead of a hard G.
I'm just old, and so
Yeah, you want to time travel and go back and tell him not to mess this up.
My knowledge of gigawatts stems from the flux capacitor.
Back to the Future. Yeah. Oh, I know.
The flux capacitor of the DeLorean. You gotta get the lightning strike to get 1.21 gigawatts.
So I have here like coal capacity output increased by 100%, gas turbine capacity increased by 450%. And again, that was at the height of the power losses. So when half of the production facilities that were operational went down, and these gas turbines are now running at 450%. So they really, like, in all reality, it could have been so bad that instead of like 4 million people losing power, we could have had like 15, 20, 30 million people without power. Right?
Yeah.
So that's just kind of like a thing of like how much can you backfill the supply? Because everyone's still demanding, right? Your motor is still locked up. Everyone's house's lights are still on. They're still trying to draw power, right?
Right.
And that's where it comes into like load balancing. When you hear the news talk about load balancing, what it is it's trying to match supply with the demand, right? And so, you know, that's where you see the supply demand curves of like, oh, there's a whole bunch of power demand during the middle of the day. Everyone's trying to stay cool in the summer in Texas. Air conditioners, the big part of why we are the #1 user of electricity in the country, right? Because it's friggin' hot here, and I'm not going to live in that. And I turn on, I'm going to crank down the AC, I'm going to put it at 69 degrees, I'm going to live my life happy, right?
Right. I'm not trying to sweat on purpose.
Yeah, I'm not trying to sweat on purpose. So, like, people up north, like, don't understand, like, oh, yeah, just open a window. No, it's 110 degrees out there. I'm not opening the window.
Yeah.
Like, I go outside when I absolutely have to.
And then turn on a fan so you move around the hot air.
Yeah. Yeah.
And then, you know, when it's humid, for those of us that live in the humid part of Texas, it's just like even the shade is not cooler. Like it's still hot. It's still hot.
And the funny thing that I always find is like, so basically, if you want to get down to like, now ERCOT's going to do their investigation, right? They're going to have a federal investigation probably. There's probably going to be a few commissions in the state of Texas that the state legislature is going to come up with to do investigations on all of this, right? So everyone's going to be doing their investigation as to like what happened, what went wrong, what could have been done better. You know, if you look in the news article, you would see that like Greg Abbott was railing against the ERCOT executive, whatever the managing director is, of ERCOT. Now, let me back up. ERCOT is basically the Electric Reliability Council of Texas. And they are basically a nonprofit, legislative directed board that kind of maintains the power grid, right? So while they are not, they are an official government body in the way that like kind of the Federal Reserve is, right? They're directed by the legislator, but they're not part of it. They're not paid. I don't think they're paid by it.
I don't know how they're paid. I did see a breakdown of how much money they pay their people.
I'm sure it's a lot.
It's a lot.
Yeah. But it's a big responsibility too. I mean, don't get me wrong, right? And
you gotta be pretty smart to be doing it.
Yeah.
You know,
you gotta
I assume.
Sure. So the long and the short of it is that, in my opinion, again, and I'm just someone familiar with the industry. I know enough about electricity to get myself in trouble with the electricians. You know, I'm much more of a mechanical guy, mechanical engineer. In my particular degree program, I did a lot of electrical power and a lot more electrical analysis than like your standard mechanical engineer that would graduate with an ME, you know. Because I did marine engineering, right? And so if you're out on a ship, you got to be able to fix everything kind of deal was their mindset. So I know enough to get myself in trouble with a lot of these things. When I run into issues at work, I still do have to go and consult the experts, but a lot of times I can figure it out, right? So that's just kind of where I'm at.
Right. A lot of times.
So anyone who's telling you that like, oh, it's all wind turbines' fault, or it's all fossil fuels' fault, the answer is they both screwed up.
Right. Well, it was just a complete system failure.
Well, it was a complete system failure, but at the end of the day, the only reason that anyone had any power, at least in the state of Texas, was because of fossil fuels. Because the wind turbines shut down first, and they did not come back up online until I think the earliest one defrosted Wednesday afternoon. So,
but even then, you really can't blame them because they didn't spend the money. Like I said, a choice was made.
A choice was made, absolutely.
You know, they absolutely, that was...
Go ahead.
Absolutely was preventable. Like, I mean, there's no way that, like, those things still function if you winterize them. So I mean, there's a money sense there that.
So do coal plants and gas plants, though. I mean, the argument cannot be made by saying like, oh, the turbines can run if you winterize them, and then not recognize the same is true for every other power plant. The fact of the matter is that in Texas, we didn't winterize anything, right? Yes,
I agree.
And there was I think I sent it to you, this 2011 commission in February, again, it was February, I think it was February 2nd and 3rd, 2011. They lost power to a bunch of homes. And at that time, I think it was like 150 or 200,000 homes had lost power due to cold weather. I probably didn't read as much of that report as I should have, but it kind of had the same messages as to what happened here, but at a lower scale, right? You had utilities freeze up, you had water lines freeze up, you had, at that point in time in 2011, the state of Texas had a much smaller wind footprint for wind energy. It was roughly about half of what it is today. Instead of being able to produce about 30%, 30,000 megawatts, I think their maximum output was about 12,000 megawatts in 2011 for wind. Most of the state was run on coal back then. And it's only been in the last decade that the gas prices and the efficiencies in gas turbines that have driven gas turbines to take over the lion's share of the market. But again, you're talking about winterization as a direct means to prevent these things. Now we're going to talk about that. That takes me into very nicely segue into credible scenario.
Okay, what does that mean?
You ready?
Yeah, I'm ready. What does that mean?
Oh, okay. So credible scenario is basically how likely is this to happen? Okay, and it's a large evaluation. I mean, that's all it really means. It's a fancy way of saying, like, is this going to happen really? So in industry, say you have let's say you've got a tank, right? And this tank operates at about 10 psi. And the tank itself is rated for like 100 psi, right? So it's 10 times the normal operating conditions. Okay, that's how strong this tank is. Yes. Now let's say I put water in the tank. Okay. Now it's seriously over-engineered, but just for the purposes of this argument, this is what's happening. I got water in this tank. It operates at about 10 psi, pounds per square inch, and then it can hold 100 psi.
Okay.
What would it take for me to overpressure that vessel? Okay, that's the question I have to ask myself, because I have to design a safety system to protect the vessel. All right. So I would sit down and I would calculate, okay, so what if the water became steam and it's blocked in, there's no way for it to escape? And so I would say, like, what?
That would build pressure.
That would build pressure, absolutely, right? So that would be a credible scenario. So then I'm looking at like a fire in the area. Is there anything that can catch fire around this tank? It's in the middle of the field. maybe, right? You know, I don't know. Maybe somebody builds a fire around it, right? Is that really a credible scenario? Like if somebody comes and piles firewood around this thing and then builds a fire and lights it on fire to blow up the tank? No. I would say that's not really a credible scenario. If I had it in the area with a lot of other chemical tanks that could catch fire, so if I had it next to a petroleum tank or something like that that could explode and catch fire on its own, you know, whatever other scenario, then that would be a credible scenario, right? Because the sun itself is not going to be able to boil the water under pressure just from hitting it, you know. So that would not be a credible scenario. So I would look at my scenarios and say, okay, so what's the situation where I have to put a relief device of some kind on this tank? And just for reference, most tanks have relief devices, most every single tank. And in fact, I think an ASME and API code both state that like if your tank can hold more than 15 PSI, like it has to have one, like period, the end. But that's just the example, right? So,
yeah.
So that would be what's considered a credible scenario. So we do this for everything, right? There are procedures for like what to do if you get a bomb threat. Like here's the procedure you pull out. What to do if the river water shuts off. Here's a procedure for that. What to do if, you know, you lose nitrogen pressure. Here's a procedure for that, you know. And these things are written and maintained by the engineers and the people who designed and operate the plant. Mostly not design, but like operate and maintain the plant. These are the procedures that kind of dictate every scenario that they would deem credible, right? I live on the coast, and so the idea that we would have a hurricane, obviously, is a very credible scenario, right? So then what do you design for? Do you design for the 500-year storm? Do you design for the 100-year storm? The 50, the 10-year storm, you know?
Here's the problem that I have with that, and just for the sake of argument.
Sure.
We're having a lot of 500-year storms lately, like a lot, and they're increasing. So we should probably prepare for those. Yes.
Which
Like,
ones?
I mean,
What's the 500-year storm?
well, I mean, just we had double hurricanes last year that were coming in at the same time. The 100-year storm that we just had. I mean, it's just like those things are increasing. They're happening more and more and more. Like how much money do we spend in fucking FEMA relief?
A lot. But I can't.
Yeah,
I don't know if they're happening any more than they ever have. Honestly, I really don't know the data on that, and I can't speak to that. But
so as a lefty, I can tell you that they're happening quite more frequently than they used to. They're called 100-year storms for a reason because it's not supposed to. They're not supposed to be happening all the time.
So the sources you read claim.
True.
I don't know the sources, and I don't have the ability to argue the point. What I do know is that a lot of these plants, at least where I live, are designed for the 100-year storm on most every single piece of equipment. For the really dangerous stuff, they're basically in concrete bunkers, right?
Yeah.
You know, if you got some methyl ethyl death over there, it's in a bunker, it's sealed, and it's inside another vessel that's pressurized with a nitrogen pad around it to make sure that what's in the inner vessel doesn't get into the outer vessel. And then the outer vessel is basically just this like concrete dome around this thing. So like that, I was like, oh, that could be like a nuclear facility right there. Like it's nice and protected. You already got the concrete wall around it. Oh no, that's just like phosgene in there, and that's really bad stuff, right? So, yeah. Anyway,
yeah. Well, let me ask you this, and this is something that I saw last night, because you've heard about now with the supply and demand stuff, the the price went through the roof, right?
Yes, I did see that.
Okay, so according to Texas code, after a declared emergency, selling or leasing fuel, medicine, food, or other necessity at an exorbitant or excessive price is subject to civil penalty up to $20,000 per violation and up to $250,000 if victim was over 65 years old, and injunctive relief. However, uh, they passed um, an emergency order on electricity pricing. So they got together on February 15th, and says, in response to the weather-induced electricity crisis currently affecting Texas, the Public Utility Commission of Texas met in an emergency open meeting to address concerns that certain pricing mechanisms were not generating an optimal response to the challenge. In its order, the commission directed ERCOT to modify pricing models to more accurately reflect the scarcity conditions of the market. Specifically, the commission directed ERCOT to ensure the firm load be shed in ERCOT's energy emergency alert level 3 operating condition is accounted for in ERCOT scarcity pricing.
Back up, read that part again.
The commission directed ERCOT to modify pricing models to more accurately reflect the scarcity conditions in the market. Specifically, the commission directed ERCOT to ensure that firm load being shed in ERCOT's energy emergency alert level 3 operating condition is accounted for in ERCOT's scarcity pricing. Mm-hmm. The decision was spurred by ERCOT's discovery that energy prices across the system were clearing at less than the current system-wide offer cap of $9,000. I'm assuming that's per megawatt hour.
I think so. Yeah. So, what is firm load? Do you know what that is?
No.
So, firm load is actually us. Right.
Okay.
So basically, what they would call a firm load is if you had 1,000 houses in an area, they're going to pull guaranteed a set amount of power. Right. Now, sometimes it might be more, sometimes it might be less, but they're guaranteed to at least pull this much. That would be the firm load. So if the legislator is coming in and saying you need to adjust prices based on your reduction of firm load, it almost reads as it sounds as though they're telling them they have to lower the prices because they're guaranteeing that they're not going to provide power to those people.
So they're saying they're capping it at $9,000?
Which is a ton of money. But yeah,
it's a lot of. I'm gonna tell you this, and this is just between you.
I can't afford $9,000 of a fucking megawatt.
I'm just gonna tell you, if they well, I think it's per megawatt hour, which is not kilowatt, because really we get charged like 7 cents per kilowatt hour or something like that.
Yeah, and all the meters on like residential houses use kilowatt hours because their voltage is so low. Like it's 120 volts. Is
so. So I'm just thinking to myself, because I've heard some speculation that people are going to be receiving some really, really, really expensive bills. The gritter people, you've heard of this, I assume. Okay, so Gritter is this company that basically charges their clients. They pay a fee to the company, and then their clients pay wholesale prices. So it's continuous wholesale pricing. So these folks, and there's not that many. They don't have that many clients. There's maybe 50,000 people on this, but they're talking about like $20,000 to $30,000 bills hitting. And so I'm just like, yeah, I dare you to hit me with something like that.
Yeah, I don't think that's
what's going to happen?
I don't think that's going to happen.
It's going in the trash. Yeah. Well, and I read the other thing that like most of our energy that we pay, for most of us, we pay it on a kind of an insurance based thing where you have a locked in price. You you pay kind of this set price, and if they're buying it, the market is lower, they get to buy it at low, and then we pay the extra whatever, right? That's how they make money.
Like,
and so
you're
when
going to
things
pay
like
at most like 12, 13 cents a kilowatt hour, but
right.
if it drops down, we'll sell it to you for less.
Well, no, if it drops down, you're going to keep paying this amount, and that's how we make money. But if it goes up, you see what I'm saying? That's how they make their money, because it's that time in between where
I've seen it both
it's
ways.
yeah. But those folks that don't have that they could be in serious trouble. But my point is like without pricing control, because the whole thing is 100% deregulated. It is what it is. Supply and demand. That's the free market, scarcity, etc. People gotta have it, and it falls back to the inelasticity of basic needs. But and then the other thing, I guess, not to get back to like some of the politics stuff, there is no way that a Democratic-controlled Texas would have changed a single thing about what happened. I've seen all over Twitter that people are like blaming Texans for voting for Republicans, blah, 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 blah. But nothing would have changed.
It wouldn't have changed either.
I also saw that your boy, Ted Cruz and Greg Abbott have collectively, over the past years, taken somewhere in the effect of $150 million combined from oil and gas companies. So, of course, they're going to go on Fox News day of and lambast green energy and the Green New Deal and say it's all their fault because it's in their interest to do so. Which, like we've talked about, there's no way that it's not everyone's fault. and ultimately, nothing was winterized because we live in Texas. And so, while yes, it was a preventable disaster, like you said, what did you call it?
Credible scenario.
Credible scenario. I mean, who thought the entire? Because realistically, when you have a freeze here in Texas, it is generally because Texas is huge, right? I mean, it's very, very big, and so when a freeze comes, it's usually regional. Mm-hmm. And so if something happens, you can pull power from other places across the state. This is the first time that it's ever been the entire state, ever, mm-hmm. which is it's bananas. So again, who would have thought this would have happened? And so it's kind of at this point for me, even being as left as I am, like it's just kind of a thing that happened, and we gotta repair, we gotta fix, we gotta do whatever we gotta do. But we're okay, I think.
Well, I mean, the thing is that it's extremely resilient, and the reason, there was an article that Dallas Morning News put out, basically where and my wife showed me this last night. It was the director of ERCOT basically saying that they were minutes away from blowing. You know, he doesn't get into the specifics of it, but it's like because of the load imbalance that happened early on, with plants going down, other plants trying to pick up the load, people still having all their lights on. So then the firm load, the demand load was still out there, but the supply load was in flux, right? There was a high probability that they almost blew every damn transformer in the state. And every major switching station, right? So
just like you said, like your circuit breaker here, when it trips, it goes out.
But
and so,
but if like we trip on like 480 volt, 240 volt, and 120, right? That's the max voltage you're ever going to have in your house. These switching stations are running thousands and thousands of volts, like 80 to 150,000 volts of electricity through them. So when they trip violently. And they tend to explode, okay? So like you've seen the movies where like the transformer on the line, the power line outside the house like blows up, you know? You've seen that in movies happen a bunch of times, right?
Yeah.
So imagine that at a scale of like a power scale like 4 times as high.
Wow. Yeah.
So it would be really bad. It could have been really bad. And the only way to prevent that is to kill it.
Well, so, and that's one thing my wife and I talked about was we're actually pretty thankful they did it. You know, we like I said, we actually never lost power all the way. You know, like where we were without for a long time, and it's probably because I live in the suburbs, and we our power's on a co-op, which I hate, by the way, because I don't have a choice. We don't have a choice.
Is it like a co-op between like Centerpoint and Reliant or something like that, or?
I don't know what it's called.
I think Centerpoint owns most of the power lines in Texas. Between Centerpoint and like AT&T, all the power lines are owned by.
Then who is Encore? What do they do?
They might be a service company. Most of the time, the work that's done on the lines is like contracted out.
Okay. Because Encore are the ones that like. Encore is the ones whenever the power goes out, they are the ones that come out and fix things. So that must be it then.
Yeah, they're probably a contractor for Centerpoint or something like that.
I got a buddy that is somebody that I know, but he's a lineman. He's been a lineman for like 20 years, forever. And man, I was thinking about him all week. I was like, that poor guy's probably just out nonstop working. And so I shot him a little DM yesterday and just said, hey man, if you need a hot meal or something, because I know I think he's working in my area. I'm like, just pop by, like,
yeah, come on by. I know you're working constantly.
This dude, it's kind of those things that like my friend that's a fireman hasn't been home at all. He, I think, is staying in a hotel away from home while he's working all these hours because he's putting in like 16, 17 hours a day. It's a tough deal, and there's a lot of people out there that are really trying to help us out. And so we just need to, that's where I was like, we need to make sure we take care of these folks. So,
yeah.
It's pretty wild.
Go
ahead.
Well, I was going to say, you said unregulated, and I have to disagree. I pulled up the Public Utility Commission of Texas, and there is a ton of stuff in here that I actually don't have time to go through. But just, it's a lot.
So, okay. Yes.
And there's the whole section in here about like cost of services, recovery of fuel costs, power capacity, cost recover factor. Like there's a whole subchapter in cost and
also, like
recouping costs, how they can do it.
The government didn't allow them to shut down power to hospitals, fire stations, water filtration systems for the most part. A a lot of homeless people were housed in convention centers run by cities. I understand that there is a regulation. Some there is some.
It's not Pemex, so it's not like U.S. Exxon, whatever, like state run. That is true, but it is heavily regulated.
So there are responsibilities that the government has protected us on,
Yes.
which is I am thankful for. The thing though is that I guess, what am I trying to say here?
It's not as regulated as you want it. Sorry.
I just I think there could be more protections.
Oh yeah.
It is a bastion of free market capitalism. Okay, so there is that, and my competition.
You dropped it.
Competition does keep those prices low, except for in my area when I have one choice, which actually it is kind of annoying. I have one choice for what I can do for electricity because of contracts with whoever.
Someone
I don't
else.
know why.
Yeah. You actually should you could look up like tort law.
Do you have one?
What? No, he kicked it into there. And it could be, you could make an argument for I don't know if it would work because you'd have to get into a contract with someone else and then basically try to say that they are interfering as a third party between a contract between two parties as tortious interference.
I have 5 children.
You don't have time for that? Is that what you're saying? Rather just pay the money? I'm just saying, if you wanted to, you could.
I have 3 children under 3 years old.
Explore avenues of anti-monopolistic practices, which I absolutely hate. So anyway, yeah, the idea that it's preventable is true. Like you said, Texas is absolutely massive. We have power plants all over. We have 2 nuclear facilities that generate somewhere in the neighborhood of 3 gigawatts apiece, which at a state that produces 81 gigawatts, that's still a healthy amount of power just through those 2 facilities. There's only 10 active, from what I could see in... Oh, I just killed your camera. From what I could see in my notes... No, there's 14 coal plants in Texas, and then basically everything else is gas turbine. I don't have a number for that one. Some of the rivers have, Whitney Dam. There's a big hydroelectric plant there.
Yeah, I actually always enjoyed going there when I was a kid.
Oh, it was great. Yeah, man. They'd open up the things. You'd see the big turbines running. And, of course, back then I didn't understand what the heck I was looking at. Now I'd love to go back because I know what I'm looking at.
Yeah. It's pretty impressive.
But, that they had to basically shut that down because of the freeze, right? Because it's a dam. It's not insulated. It's concrete walls. And metal pipes running through it. So, I got something in my eye. In any case, there were a lot of things that went wrong. And then, of course, when people lost power, they lost heat, and then their attic froze, and so the water pipes that were uninsulated in the attic burst. And, a lot of people, you see the videos on the TikToks and the YouTubes and the things that, there's just water just coming in, and then the ceiling falls out, I guess one silver lining, and I hate using silver linings, is that a lot of the damages in this case are going to be covered under homeowners insurance, and they won't actually have to deal with TWIA. Now, I think we're going to see a huge spate of insurance companies not wanting to pay up and everything else. That always happens in major events like this. Unfortunately.
Well, I'll say this: my buddy that had to move out of his house because of the flooding didn't even know about. Like, he made a claim and didn't even know about the accommodation
that they had in his
insurance that his insurance gets. So when he told me about it, I was like, hey, I was like, they should put you up in a hotel. And he was like, what? I was like, you have in your insurance under major catastrophes an accommodation clause or whatever it's called. Mm-hmm. I said, talk to your agent or talk to somebody, but you need to get on that and
pay for it and use it.
Right. I was like, they should put you up somewhere comparable until you can move back in. And we had people that, like, their insurance companies rented a house for 6 months because it was going to take so long. This is when I was doing fire restoration.
Right.
But
that's like one-off things. Like, when Harvey hit Houston, it was everyone essentially.
Oh yeah, and
like
even the hotels. Yeah.
And so, like,
there's nowhere to put everyone. And so a lot of times they were doing like, it definitely wasn't comparable, but like FEMA brought in like connexes and put up like tent cities and like the parks in Houston. It was a disaster, man. But it's just the scale of it was so big, So yeah.
And around here we had a guy who basically, it took him. I felt so bad for him. He lives in a neighborhood around here that kind of floods frequently, or at least he used to. And he got flooded out, and so we had this big problem where like the river upstream flooded, and it flooded a big portion of the area around here. And then like a year later, so he spent a year like in a hotel or at his brother's house, living with his brother, getting his house redone. And then Harvey hit, and it flooded again. I'm not going to make this up. So he rebuilt it again, redid all the sheetrock and everything else twice within a 3-year time span. And he moved up to Pearland. He's like, I'm out of here. I'm going to sell this house to some other sucker.
Right. So, do you want to? We kind of beat that one into the ground. What else were we going to talk about before? We went under for a week.
I don't know. I feel like we got about 20 minutes left to hit something.
Can we talk about how disgusting this thing is that I found out about? Slabs. Did you ever look that up?
I did. I didn't have time to get into it too much, but it was student loan asset-backed securities.
Yes.
I think.
Student loan. So essentially, from what I've read, these are the same things that they did with the subprime mortgage crisis. So basically, they're taking all of these student loans. Now, I don't know if they're taking the ones that are owned by the government, and these may just be federal or not privately owned student loans. They're federally backed, but they're privately owned. So I don't know if that's all $1.53 trillion.
In the article you sent me, it was saying that they were more risky because they were no longer federally backed. These particular loans.
Okay, so these are definitely not the federal ones. Okay,
I think I remember seeing that in the article you sent me. And I remember thinking like, oh, who's giving these out? That's weird.
The thing that like hurts my heart is knowing that our representatives, it's a fun talking point. That's all it is at this point, unless something changes
What, student loan
magically. Yeah, student
forgiveness?
loan forgiveness
I mean,
is a fun
Biden
talking
basically
point.
he looked at the reporter or the kid who asked him about it, and they were like, "Are you gonna get 50,000 student loan forgiveness?" He's just like, "No."
Yeah,
Like he actually gave a straight answer on that one.
yeah. So Biden sucks. Um, he sucks huge donkey penines. Yeah. So yeah, it's just like it's it's the same shit with the subprime mortgage crisis. They package up apparently they're packaging up these student loans, and they're breaking them up and selling them out as securities and dividends, and they're trading them back and forth to make money off of them. This
So what you need to
is
do
crazy.
basically is you've identified the next short. Is that what you're implying here? Because it's obviously a bubble and it's obviously going to burst.
Probably because people aren't going to pay them.
I mean, well, 35 is it 35? 35% of all student loans are in arrears.
Yeah.
And it's like it's something astronomical like that. Like
There's a large number of people that just don't pay them.
yeah, it's just like whatever. I'm working at Starbucks. I didn't get anything for my degree, so I'm not going to pay back this loan that I given, to go to school. I mean, we were very fortunate to have a grandfather that invested in Oracle when it was a startup company. You remember?
Uh-huh.
Yeah, and then it grew and split and grew and split and grew and split and grew and split. And so our grandfather was able to basically have college funds for all of the grandkids.
Yeah.
All of them. Right? That's it. That's where he put all his money. Right? So, cool. Great. Very, very fortunate. Winning the lottery, basically on a stock like he did. That being said, I went to college as a theater major initially. You remember?
Yeah. Yep.
And at one point, I decided that these people were crazy. No. So first off, I was doing theater, and I would do things like show up to a final still drunk, and then make like an A on it. And I was like, man, this isn't. I'm wasting my time here. Like if I wanted to be an actor, I should just move to Hollywood, but I don't want to move to Hollywood, so I was very, very left in my political opinions back then, in those days.
Yeah.
And then I went to do like theater design because I was like, well, I want to eat, and there's usually room for a carpenter, doing that work. And then I went to one party one time, and I remember walking up to the front door, and there was somebody outside crying, and all her little friends around her. And so I'm like, wow, what's going on here? And they're like, oh, nothing. This is the right house. You're here for the party. And I'm like, yeah, but why is it crying outside? I'm like, okay, she got into a fight with somebody. It's fine. So I walk in, and there's somebody like sitting on the couch, like right in front of the front door, bawling their eyes out because she got into a fight with this person out front. And I'm like, well, that's weird. Okay. So I'm like, where's the beer? Beer's in the fridge. Okay, so I walk into the kitchen. I'm kind of standing there, and I smoked it this time. So I was like, man, I'll get my beer. I'm gonna go smoke a cigarette. And I walk through the bedrooms. They're like, oh, you got to go through this guy's bedroom back to the patio in the back. Okay, yeah, because I don't want to go out front because there's drama out there. And I go in there, and the guy whose apartment it was is like fussing about his girlfriend, and he's almost in tears about it. And then I get out to the patio, and the girlfriend's out there, and she's like full blown meltdown, everything else, and I'm just sipping my drink and smoking my cigarette, just like, you know what? This party sucks.
Literally. drama queen.
Literally drama queens. All of you. I'm out of here. Like, finished it up, walked right back to my car, and called my friend up who was at the another place down the street. So this was supposed to be like the after show party, and it was about that time where I was just like, I gotta get out of here. I wanna eat more than ramen noodles as an adult. And I remember I asked the director, the set director. We built this big set. And I remember asking him, like, well, how do we know it's not going to fall down? Because it was this 2-story monstrosity that was on wheels and it had to rotate on stage and everything else. It was really big. And I remember asking him, like, how do we know it's not going to collapse? Because people are going to be running up and down the stairs and, like, falling and tripping and running in and out and slamming the doors and all this other stuff. And this thing could fall over. Like, he's like, nah, we built it out of good 2x4, so I'm pretty sure it won't. And I didn't really like that answer. So, yeah.
Right on. Right on.
It's kind of how I was like, yeah, I'm going to go from theater to engineering. This is a great choice.
So figure out.
Dad was thrilled, by the way. Yeah.
Well, my oldest son is a theater major. And, but I think he's going to get a teaching certificate with it.
He told me he wanted to teach. Because I remember you asked me to talk to him, like, how are you going to eat?
Yeah.
This is important.
So that's cool. So I have to tell you this. Remember a while back we were talking about intersectionality. And,
yes.
And so our the people that watch the show are basically the people that know us.
Like personally.
Nobody else. Yeah. So anyway, they watched the show on intersectionality, and the analogy that I gave was the Chad analogy, right? Where the Chads don't understand whatever that they have power. So my group of friends, they're like, "Hey, what's a Chad?" And I had to be like, you were a Chad. They're like, what does that mean? I was like, so you were popular with the ladies. You didn't even have to have game. You could just especially my friend who was asking, because he has like the longest eyelashes ever. And,
so he's just like blinks them.
And so like he got so much action when we were younger. Now we're all old and fat, and so it doesn't really happen for us anymore. But yeah, like the entire group, and so we all started arguing about who the bigger Chad was, and so it's just, yeah, it was just kind of funny where how oblivious we were then.
Yeah.
And apparently still are, but I always knew my power.
Yeah, you recognize your ability with the opposite sex. So
there was one time, I think I don't know if you remember, but the one time after I got divorced, and I went down to a party with you at Baylor, and then within 5 minutes I was making out with some girl.
Yeah.
And your friends are like, "What? He just got here."
Yeah. It's like 5 minutes in. You like later on, you were like, "I don't think she's wearing any underwear." So I was laughing pretty hard at that. I still remember that trip. That was a good trip. That was when we went down to go see your buddy's band, right?
Yeah.
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 We got there early. Yeah. God, that was good times.
Good time.
That was a long time ago too.
Again, that was 70 pounds ago.
Yeah. Well, I thought about what you were saying about that actually the other day, and I was thinking like, it's interesting because on a lot of the the message boards that cater to those guys, right? Like I don't want to name drop the bros or whatever, but like the men's self-help group, I guess you could call it, right?
Is that?
It's the nice way of putting it.
Incel a little bit.
Yes, the incels, and they're basically like the how not to be this way, and they never say just be yourself. Ever.
Step one, be attractive. Step two, don't be unattractive.
Step one is go lift a weight. It's like, you can be ugly.
Yeah.
You, like, if you're having problems, go lift a weight. Pick up a heavy thing and put it down. And then it says, and the number two thing is just like, get a hobby. Like, find something you're interested in and passionate about and do it.
Yeah.
And find someone who can support you doing something you love. And so it's like, oh, that's not terrible advice. That's not BS. It's really like, not. Hey, go be yourself. No, just be yourself, man. It'll be fine. No, it's like, work on yourself, make yourself better and more attractive in any way you can, which is pick up a weight and put it down again and then do it over and over and over again. And then find something you like to do, which you can be passionate about.
I lift a lot of weights, and I'm still fat.
You also, I've been to your house when you have dinner, and you guys have a 4-course feast every time I've ever come to see you guys. And I don't know if y'all are just like showing off for me when I'm
we're
there.
Showing off for you.
Okay. I'm just like, I've been to your house, man. Like,
we're showing off.
Y'all put out a spread that would make Henry VIII jealous. Like,
yeah. No, we're that's when we're hosting and we're putting on a show.
Oh, okay. That's not normal. All right. That's fair. I do that too.
Not to say that I don't overeat. I'm just saying.
I guess other notes in the news. 10-minute wrap up.
Okay.
I want to say, so the slabs are bad, and it's the next housing bubble. We'll definitely keep an eye on that.
Yep.
I'm really curious as to what's going to happen between Facebook and Australia. I think I sent you that story. The basic premise is that Australia was working on a bill to force Facebook to pay a percentage of advertising profit to the local publishers. So like the Sky News Australia or whoever else is producing the news.
Right.
When those links are clicked on through Facebook, they would then have to pay. Facebook would have to pay the publisher for providing that service. So what Facebook did was they banned everybody. They blocked all news and government and emergency services. So basically, anyone affiliated with the Australian government and all of their news sources could not be linked or shared on Facebook in Australia.
Yeah.
So Facebook said, do something. We're sorry. We didn't mean to block your emergency services, but watch out because we can. Like,
yeah. I hear you're thinking about passing a bill.
I hear you were thinking about passing a bill that would take money from us, and we like our money, so we want you to not do that.
Let me show you what happens.
Let me show you what we can do.
Yeah.
So the parliamentarians are pissed, obviously, on both sides.
Obviously.
So I think they are going to definitely have a very strong bipartisan agreement on whatever path they pursue. I guess it remains to be seen as to what that is. Yeah.
Yeah.
I don't know what's going to happen from that, but it's definitely a thing going on right now.
It might be something for everybody across the world to watch, and because at the end of the day, a lot of Facebook is under suit, Twitter's under. I mean, a lot of these things are really pissing off a lot of people, but
48
they're all still on them.
Yeah. Well,
I mean, I'm sitting here, I'm looking at a tweet right now from Donald Trump Jr. And he's telling on Twitter to go to Rumble.com. I don't know what Rumble.com
Rumble is a backup YouTube. It's an alt YouTube kind of thing.
So that's where the DTJ is going.
Yeah, and then you have Gab, which is the alt Twitter, and I think Parler's back up, but it's mostly dead now, from what I can tell.
It's so funny because I see all of my Republican friends, because, I live here. So all the people that I know are pretty much Republican. Mm-hmm. That's just how that is. But they all keep talking about where to go while posting on Facebook. Like you're going to, you keep posting here and you keep posting stories on Facebook while you talk about how much you hate Facebook.
But all their friends are on Facebook, man. It's hard to disconnect yourself from some of these things, and I get it. It's psychological, but I mean, deleting your Facebook profile is easy, if you want to do it.
I kind of want to, man. I'm almost to the point where I'm ready to delete my Facebook profile. Yeah. And because it's all that I see is just stupid misinformation, dumb shit,
yeah.
It drives me crazy. I can't stand it.
Yeah. Someone very close to me had deleted their Facebook and was much happier for it. So.
Oh yeah.
Yeah.
Speaking of, I was telling my wife the other day that we're gonna have to pay more attention on Insta, because we'll get more pictures of the baby.
Yeah. It's just nobody can spout their opinions on the IG like they can on the FB. So. Yeah. It's much more like food and cats and stuff.
Yeah, that's what I was thinking. I told her, I was like, we're gonna have to get on there.
Yeah.
I was like, look at this, because she had just posted some pictures of the baby.
Yeah.
I was like, look at here. Look at all these. I didn't see these.
Yeah.
Why are we on Instagram?
So
there's so much though to keep track of. I get worn out with, my own personal Twitter, the BroPartisan Twitter, my own personal Facebook, the BroPartisan Facebook. It's a lot to maintain.
Yeah.
Especially since I've decided that I'm going to be in charge of all the social media. Speaking of which, everyone, I do all the social media, so if it seems really, really skewed, that's me.
It's his fault. I had to create my own thing for that, just to disagree with you on one point, I think. So it's no, I can't let that one go. What else did I put down here? Gavin Newsom about to get recalled. He wants to do a signature verification this time to make sure that all the people who signed the signatures. And so the Republicans, of course, are pissed because they're like, oh, now you want to do signature verification on these envelopes and these signatures, huh? Now it's so important for you to make sure that nothing was wrong. Interesting, Mr. Newsom. That's great. Governor Cuomo's in hot water, if you saw that.
Yeah, I think that's pretty bipartisan too.
Everybody's pissed.
Governor Cuomo thing. It's he's in some trouble.
Yeah. Governor Cuomo, the Democrats want to strip Governor Cuomo of all the coronavirus emergency powers following the nursing home cover-up. He probably shouldn't have ordered sick people out of those two empty hospitals, military hospitals that they had in New York, and sent them to nursing homes. It's probably a bad call.
I don't know why he did that.
I don't know. But it was very interesting to see both CNN and Breitbart writing the same story on that particular piece. That was very interesting.
Ted Cruz is a dumbass.
Yes. Yeah.
I mean, really, like at the end of the day, I get it. I
Well,
absolutely
I'm gonna
get
go
it
to
because
Cancun.
well,
It's
you
cold
know,
in Texas.
here's the
Man.
thing. Here's the thing. You know, we've all been with our family, and when the wife decides she wants to do something, you're like, okay, yeah, let's do that. Like you're
Yeah, you're not
whatever.
gonna like back out of it. Like, oh, the plant's down. I need to work. No, we scheduled this months ago. You're going.
Right. The wife and kids decide it's a thing. We're going. That's it. And so, on one hand, I understand. I get it because it seemed like his family was like, "Hey, we're gonna go.
Yeah.
You need to be with us," and and so he did, and just not thinking. And I will give him the props for saying, you know what, I've made a mistake. All right,
I probably need to get back.
Wasn't a good idea. So.
Oh, gotta
I
help
can
her now.
see by the corner of your screen it's probably time to go.
Yeah, we're right at 2 hours, so I think it's a good place to wrap up. That's basically all my bits I was wanting to hit on.
All right, well, good conversation.
Yeah. If any of your buddies have questions, have them posted in the comments. We can get some traction on this thing.
Yeah, absolutely. Hopefully this was pretty explanatory for folks today. So, yeah, if you guys have questions, if you want to, mention something that maybe we forgot or we didn't know about, put it in the comments.
Yep. I'm still looking. So, like I said, there's going to be a ton of investigations about this. There's going to be a lot more stuff that comes to light. Everyone's going to have a commission on this.
Yep.
We'll see what happens. But for now, lights are back on for us. So, yay.
Amen.
All right, man. You have a good one.
You too. Thank you for watching this episode of BroPartisan Hacks with Reese and Rob. We really, really appreciate you watching, tuning in. If you like this video, please hit the like button. Please subscribe to us. We're putting out content as often as we can. Share it with your friends. Get it out there. Get our names out there. Also, hit that bell, tap that bell right there so that you can get updated when we put out a new video. Rob and I are trying to pump these videos out as often as we can. However, we both have day jobs, we have families, so our schedules have to line up so that we can make a new video. Speaking of our day jobs, our opinions and views expressed are our own and in no way represent those of our respective employers. Thank you. Thanks again for watching.